Okay, so we've all heard of black holes, right? The universe's ultimate one-way street. But what if there's an exit? What if there's a cosmic door that only lets things out? Well, that is the absolutely mind-bending idea we are diving into today, the white hole.
Just look at this. Imagine the perfect, exact mirror image of a black hole. Not some cosmic drain where everything vanishes forever, but a cosmic fountain, violently gushing out matter and energy. That's the theory. That's the vision of a white hole. And this really leads to a huge question, doesn't it? If a black hole is a cosmic point of no return for anything that falls in, does the universe also have an exit door? A point of no return, but in the complete opposite direction? That's the mystery we're going to try and unpack. All right, first up, a cosmic opposite. To really get a handle on what a white hole might be, we have to start with its super famous twin and really see how they are perfect mathematical opposites. So here's the core definition, straight from the wild world of general relativity. A white hole is a place you literally cannot get into, no matter what you do. Instead, it's a source, just spewing out matter and energy. It's a perfect, beautiful reversal of a black hole. Let's break it down side by side. The difference is just fundamental. A black hole pulls, a white hole pushes. You can't escape a black hole's event horizon, and you can't even get to a white hole's. One is the ultimate trap, the other the ultimate fountain. They really are two sides of the very same mathematical coin. So where on earth did this wild idea even come from? Well, you might be surprised to learn astronomers didn't find white holes by peering through telescopes. Nope, they found them hiding in plain sight, right inside the mathematics of the universe. They're like ghosts in the equations. And this quote from the one and only Stephen Hawking, it gets right to the heart of it. See, the laws of physics, for the most part, don't really care if time is running forwards or backwards. So if you can have a process like a black hole sucking things in, the equations say, sure, you can also run the film backward and have an object spitting things out. And this idea, it's been kicking around for a while. It first popped up way back in the 1930s, pretty much as a mathematical curiosity in Einstein's equations. It wasn't until the 60s that scientists like Igor Novikov started asking, hey, wait a minute, could this actually be a real thing? And then Hawking came along and really sealed the deal, identifying it as the time-reverse twin of a black hole. Okay, now this looks complicated, I know, but stick with me. This is basically a map of spacetime for a perfect, theoretical, eternal black hole. And the math behind this map, it reveals something really strange. For the map to be complete, an eternal black hole in the future requires a white hole in its past. And that's the crucial part right there. This only works for a perfect, idealized black hole that has existed forever. For that specific case, general relativity basically demands that it must have come from a white hole. The math just links them together. The white hole is its past, and the black hole is its future. It's a package deal. Okay, so if there are these cosmic fountains, what would it actually be like to run into one? What are its properties? Let's get weird. This is probably one of the trippiest parts. Unlike a black hole, where crossing the event horizon is a done deal once you get too close, you could never, ever, ever cross the event horizon of a white hole. Why? Because space-time itself is rushing away from the center faster than the speed of light. It's a totally impenetrable barrier. And just like with its dark twin, time goes haywire. If you were watching a spaceship try to fly up to a white hole's event horizon, you would see it slow down, getting closer and closer, but it would take literally an infinite amount of your time to ever actually get there. It would never arrive. So if the math works, and the concept is so cool, why have we never, ever seen one? Well, it turns out there are some pretty major hurdles to a white hole actually existing out there in our universe. Yeah, there are a few deal breakers. First, how do they form? We know giant collapsing stars make black holes, but we have absolutely no idea what physical process could make a white hole. Second, they'd be unbelievably unstable. I mean, theory suggests even a single particle of light, just one photon, could cause it to instantly collapse into a black hole. And finally, and this is the big one, real black holes, the ones made from stars, they don't need a white hole in their past. That math only works for the purely theoretical eternal kind. So the only way a white hole could possibly exist is if it was just there, right from the very beginning of the universe. It would have to have been part of the universe's starting package, a special condition that, honestly, physicists haven't found any reason to believe was there. But, and this is a really big but, that doesn't mean the idea is totally dead. In fact, this is where it gets really speculative and, frankly, super exciting. Physicists have tried to connect white holes to the biggest event of all time. Just think about it for a second. An event deep in the past from which all the matter and energy in our entire universe erupted from a single point. An event that, by definition, we cannot enter. Sound familiar? Yeah, some theories actually propose that our Big Bang was, for all intents and purposes, the explosion of a supermassive white hole.
And here's another mind melter for you. What if, when a black hole forms, the singularity at its core triggers a new Big Bang, creating a brand new baby universe? From the perspective of anyone living in that new universe, their origin point, which is our black hole, would look just like a white hole. Our entire universe could just be one of many, born from a black hole in some parent universe. Wow. And this isn't all just scribbles on a blackboard. There has been at least one real attempt to find one. Back in 2006, there was this super powerful, really unusual gamma ray burst. It was so strange that a few astronomers actually suggested it might be the signature of a white hole's small bang, a spontaneous eruption of matter. It's a total long shot, but it just goes to show you that scientists are still looking.
So, after all this, where do we land? Are white holes out there, just waiting for us to find them? Or are they just a beautiful idea, a fantasy cooked up by the math? Well, the current scientific consensus is pretty clear. As this quote lays out, the vast majority of scientists see white holes as a really fascinating result of Einstein's equations, but probably not something that actually exists in our physical reality. So let's just recap the big takeaways here. While white holes are totally possible in the math, a perfect time reversal of a black hole, there is zero observational evidence for them and some huge physical problems with their existence. Still, even as just a thought experiment, they are an incredibly valuable tool for pushing the absolute boundaries of what we know about space-time and gravity. And that leaves us with one final huge thought. Is the white hole just a dead end in our cosmic search? A beautiful mathematical ghost? Or is the fact that our very best theories predict them, even if we can't find them, is that a hint? A signpost pointing to a new, deeper kind of physics that we just don't understand yet? What do you think?